Welcome to our lesson on circumference. This is the second part of a two-part lesson essentially on circumference. In this one we look at a little bit more complicated shapes and try and get, again, the perimeter of shapes that have circles or partial circles in them. So first off, quick review. If we want to find the perimeter of this circle, that's saying we need to find the circumference. They're the same thing. So the circumference formula is pi times d, or pi times the diameter. In this case, we're given the diameter as 23 feet. So pi times 23 can also be written as 23 pi, because we usually like to put our number before our variable in this case. And with this, 23 pi really doesn't mean anything. I mean, to me, it might mean something sort of, but if I were to say, well, it's 23 feet across and it's 23 pi feet all the way around it, it wouldn't really make much sense. So in this lesson, we're going to actually convert all of our things to approximations that will help us know approximately what it is. It's approximately 72.26 feet all the way around the outside of the perimeter of this circle. Okay, if it was 23 feet across, it'd be 72.26 feet all the way around. That's something I can relate to. I know what 72 feet is. You know, it would be a lot harder for me to think of what is 23 pi feet. All right? Okay, let's move on to a crazy looking shape. And my weird equation that I came up with here. This is a circle that has a chunk taken out of it, and what we're going to do is we're going to find the perimeter of this shape, given just the radius of 3 centimeters. If we're given the radius, we can find the circumference of the whole circle using this equation, 2 pi r. But we're only going 3/4 of the way around. You see this? This is a 90-degree angle, so that's 1/4. So from here all the way around is 3/4 of my circumference. So my circumference is here, 2 pi r, but I'm going to say I want 3/4 of that circumference. Okay, I hope that makes sense. So 3/4 of the circumference is 3/4 times my circumference equation of 2 pi r. And then that will give me the distance from here all the way around to here. Then I have to add my radius times 1 and my radius a second time times 2. So that's where I have my radius times 2 over there. And this should actually read P for perimeter, not C. Okay? So my perimeter is then going to be 3/4 of 2 pi times 3. I'm adding my radius there and my radius there. And that should help me find what my radius is. I can go ahead and start simplifying a little bit. 3 times 2 is 6. 3 times 2 is 6. You'll see that reflected in the next one where I just have 6 pi plus 6. And 3/4 times 6 pi, well, 3 times 6 is 18. So I could simplify this a little bit more and say 18 over 4 pi plus 6. And at this point, I would probably pull out my calculator and say 18 over 4 times 3.14 plus 6 and get my final answer that the perimeter of this shape is about 20.14. centimeters. So if I start here and I go all the way around the perimeter, all around the outside of this shape, I will find that it is 20.14 centimeters approximately, give or take a 1,000th of a centimeter. So now I'm going to solve the next question, because it says solve, and I like to follow directions. My bicycle tire has a radius of 45 centimeters. If I hear a click every time it goes around once, how far have I gone when it has clicked 243 times? And I'm going to it says right in the instructions to use the approximation that pi is equal to 3.14. So let's think about what this means. If your bike tire starts and goes all the way around and clicks, you've gone forward with your bicycle the distance of the circumference of that tire. All right? So what we are asking, what this is asking, is what is the circumference of our tire? So let's first figure that out. Use our circumference equation. Circumference is equal to 2 times pi times the radius, because we're given radius. We can substitute the value of 45 centimeters right into that equation, and we can substitute the value of 3.14 into our equation. Multiply that out and get our answer. We know that the circumference is equal to 282 centimeters. That's the circumference of our bike tire. So let's say we're not doing tricks too much. That means we're on the ground and the tire goes around one full time. It's going to go all the way around and boom, we're going to hit it again. In that time, we have gone the distance of 2.82 centimeters, or about 2.8 meters. All right? Now, back to the question. It clicks every time it goes around. So I guess this started to get annoying, and you started counting, and you counted 243 clicks. What we want to do to find the distance then is that we're going to multiply the distance from when it goes around one time times however many times it went around. So the distance is equal to the circumference times the number of rotations, or the number of clicks in this case. All right, I'm going to substitute my value for circumference right into my equation there. Solve, probably use the calculator for this step, and I'll get that my distance is 68,671.8 centimeters. Now, if you have any idea how long that is, it seems like it's really long because it's 68,000 centimeters. But let's go ahead and I'm going to take this one step farther and actually convert it into meters, because this is something that's a little bit more reasonable. It's about 686 meters, or almost 687 meters. All right. I just rounded it down to being 686 meters, and that's something that gives me a little bit more of a distance. I could go even one step farther and make it into kilometers, but we don't need to do that. This makes it a little bit more measurable. Anyone who runs track, you know what the 400-meter dash is. So this is somewhere between the 400-meter dash and the 800-meter dash. All right? Okay, so it's about like 1.5 times around a track. Anyway, so just to give you something that is a little bit more measurable than 68,000 centimeters. All right, you wouldn't probably have to do this unless they gave the final answer in meters, but I just decided that I would. So there's some work with circumference. We've gone over some word problems and some crazy looking shapes, and just a quick review over what circumference was. I hope all of you have a well-rounded day, and I will see you next time.